There's a powder sitting on the shelf of your local hardware store right now. It costs $3. It has been sitting there for decades, largely ignored by the average homeowner, overlooked in favor of sleek machines with digital displays and monthly maintenance schedules. That powder does not control humidity. It does not manage moisture or slow it down or temporarily absorb it. It converts moisture into solid matter, chemically and permanently, with no electricity, no filter, no moving parts, and no ongoing cost beyond the occasional $3 replacement bag. Builders have been packing this material into foundations for over a century. Military engineers used it in bunker walls during both World Wars. Victorian engineers used it in 1850s stone tunnels that are still standing completely dry and structurally intact today, 170 years later, with zero maintenance, zero repairs, and zero electricity consumed. The chemistry behind it is not secret. The science is not complicated. The compound is not rare or hard to find. And yet, 60% of American homes have a persistent humidity problem. Not because the solution does not exist, not because the science is unclear, but because a $15 billion industry has made very deliberate decisions about what you are allowed to easily know. This is the story of hydrated lime, the powder the waterproofing industry would prefer you never seriously consider. The scale of the problem. Before we get into the chemistry and the history, it is worth sitting with the scale of the problem for a moment, because most homeowners dramatically underestimate just how common moisture damage actually is. The Environmental Protection Agency conducted a large-scale survey that covered more than 4,000 homes across 8 different states. What they found was striking. 60% of those homes showed active moisture damage at or below the foundation level. That is not a small number, and it is not an outlier result. 60% translates to roughly 80 million households across the United States, 80 million wet basements, 80 million crawl spaces with elevated humidity, 80 million homes where the air below the living space carries more moisture than it should, feeding mold growth, accelerating wood rot, corroding rebar, and slowly eating away at the structural integrity of the building from the ground up. And it is not cosmetic damage we are talking about. The EPA study found that in half of the cases surveyed, the damage had already moved beyond surface staining into structural territory. Wood rot in floor joists, rust forming along embedded rebar, concrete that had begun to crumble beneath its protective coating. These are expensive problems. These are problems that, once they have progressed far enough, require serious intervention, the kind that costs thousands of dollars and does not always produce permanent results. The standard homeowner response to a humid basement is remarkably predictable. You notice the smell first, that particular musty odor that signals biological activity in the air, mold spores colonizing damp surfaces. Then you see the stains on the walls, dark patches that return within weeks of being scrubbed. You buy a dehumidifier, perhaps a mid-range model that costs around $300, and you run it every night. Your electricity bill goes up. The machine fills with water constantly and requires regular emptying or a drain line. You buy desiccant crystals from the hardware store and replace them every few days because they saturate almost immediately. Eventually you call a contractor. The quote comes back at $4,000, $5,000, sometimes $6,000 or more. You pay it. The moisture returns within a few years anyway, and the cycle continues. This is not a maintenance problem. This is a business model. Edward Dobson and the discovery that changed nothing. The year is 1834. A Quaker chemist named Edward Dobson is working just outside London, and he is trying to solve a problem that has plagued builders for as long as buildings have existed. Underground moisture, the slow, invisible enemy of stone, brick, mortar, and wood, had been destroying structures for centuries. Builders knew it was happening. They had developed various strategies to slow it down, but nobody had produced a clean scientific explanation of the mechanism, and nobody had found a truly permanent solution. Dobson was not working with exotic materials. He was working with lime, a material builders had been mixing into mortar since the Romans constructed their roads across Europe. Lime was not new. What Dobson was the first to formally document was exactly what lime does to moisture in the air around it. His finding, once you understand it, is so straightforward and so clearly useful that it is almost difficult to believe it has not become common household knowledge in the nearly 2 centuries since he published it. Calcium hydroxide, the scientific name for hydrated lime, does not absorb moisture the way a sponge absorbs water or the way a desiccant crystal holds it temporarily until it becomes saturated. It does something fundamentally different. It reacts chemically with water molecules in the air. That reaction is called carbonation, and it produces calcium carbonate, which is simply limestone. The moisture is not stored. It is not temporarily held. It is converted into solid mineral matter. And because the reaction permanently changes the chemical structure of both the lime and the water, it cannot be reversed. The moisture is gone. Not relocated, not deferred. Gone. Dobson's research was applied almost immediately by engineers working on the Victorian infrastructure projects that were reshaping Britain in the mid-1800s. Railway tunnel construction was one of the most urgent applications. Underground tunnels cut through soil and rock that is perpetually saturated with groundwater. Keeping those tunnels dry and stable was a serious engineering challenge. Engineers who packed hydrated lime into the walls of their tunnel sections reported something consistent and remarkable. Those sections stayed dry. The untreated sections showed constant seepage, mineral deposits, structural weeping. The lime-treated sections were bone dry and remained that way. The tunnels built using this method in the 1850s are still standing today. Not restored, not reinforced, not maintained with modern waterproofing systems, standing dry and solid on the original lime treatment from over 170 years ago. That is not a coincidence. That is chemistry doing exactly what Dobson documented it doing. How the science works. To understand why hydrated lime works as a permanent humidity solution, it helps to understand the mechanism that causes moisture problems in the first place. The walls and floors of a basement or crawl space are porous. Concrete, brick, mortar, and most natural stone are full of microscopic channels and voids. Outside those walls, the soil is typically saturated with water, especially after rain, during seasonal thaws, or in regions with high water tables. That water is not just sitting there passively, it is under pressure. Vapor pressure, the tendency of water molecules to move from areas of higher concentration to areas of lower concentration, pushes moisture through those porous walls continuously. This is why waterproof paint applied to the interior of a basement wall often fails. The pressure is coming from the outside. Paint on the inside cannot stop vapor moving through the wall itself. Conventional dehumidifiers address this by pulling moisture out of the air after it has already entered the space. They are managing a symptom rather than addressing the source. The vapor continues to push through the walls at the same rate. The machine simply works to extract it from the air once it has already arrived. This is why dehumidifiers must run continuously to maintain results. The moment you turn one off, the humidity climbs back to its previous level because the source of the moisture has not changed at all.